Each day, we're coming into contact more and more with artificial intelligence and machine learning that's meant to make our lives better. We've all had some AI experiences that have gone really well, and perhaps we didn't even realize AI was helping us at first. On the other hand, getting help from AI doesn't always work out perfectly, at least not right away. So why the inconsistency? If the human mind can take in so much complex information and make sense of it, why can't our computers? Or can they, if they have good data to learn from? Brad Porter, CTO of ScaleAI, believes the key to AI learning efficiently is the right labeling.
What you need is those samples to be labeled perfectly. Because if they're labeled ambiguously, then the model can't actually decide what exactly is signal versus noise. So one way to solve that is to throw more and more data at it. Eventually, you have enough data that the algorithms learn, okay, this is the signal and all these other pieces are the noise. If you get really high quality signal though, you can learn that signal very quickly if there's not a lot of noise in it.
Computers need lots of data to learn. More accurately, they need lots of quality data labeled properly. Fundamentally, this just makes sense. The best way to learn something is through repeated exposure and practice. This is just as true for people as it is for computers. That's where Brad comes in. On this episode of IT Visionaries, Brad explains how his diverse work experience, particularly his work in robotics, ultimately led him to focus on solving the problem of data labeling for AI, which is setting us up for an exciting future. After all, if proper labeling is the key, and the key is becoming more readily available, then we can expect great things in the AI space. Brad discusses some of those great things, including how the tech will help us understand medical histories and its use in autonomous vehicles. Enjoy the episode.
IT Visionaries is created by the team at mission.org and brought to you by Salesforce Platform, the #1 cloud platform for digital transformation of every experience. Innovate fast, empower every employee, and scale with confidence from anywhere, with a customer at the center of everything you do. Learn more at salesforce.com/platform.
Welcome everyone to another episode of IT Visionaries, and today we have the CTO of ScaleAI, Brad Porter. Brad, welcome to the show.
Hi, thank you for having me.
All right out the gate, we ask all of our guests, what is ScaleAI and exactly what does it do?
Yeah, ScaleAI is a technology company based in San Francisco that was founded 5 years ago with the goal to accelerate the development of AI into production and really focused initially on the data bottleneck. Training ML models is all about the data and the quality of the data. And yet, just because you have a large data set doesn't mean you have it set up, annotated, labeled in order to train AI against it. And so Scale was founded to solve that problem, has done an incredible amount of work in really high quality, very complicated data labeling use cases, autonomous vehicles, document processing, wide array. And now really Scale is expanding to be an end-to-end AI infrastructure, but again, focused around the data, realizing that data is how you program ML models. And so the tooling, the systems we're developing really are enabling people to accelerate their model development, improve their models by really focusing on understanding their data.
So, I'd love for you to have some examples or use some examples so our audience can understand that a little better. I looked at the homepage and I saw a pretty good one, which was this idea that if you ask a person to read this paragraph, hey, they were delighted by the Hilton's location, surrounded by vibrant nightlife and in close proximity to major landmarks in Paris. And as luck would have it, Paris Hilton happened to be staying in the room next door. So this example is interchangeably using Hilton in Paris. One is the business, one is the location, and then of course, Paris Hilton is the name of a person. And you're saying you can actually train a tool to recognize these differences, to recognize one's an organization, one's a place, and one's a person.
You can.
Talk a little bit about that use case, well, that example that's on the page, and talk about what goes into programming something like that.
You can, but the computer can't just figure it out. Like your machine learning models can't just figure it out without someone helping it understand Paris in this context is a city, is a location. Paris in this context is a person, is a celebrity, right? And if you label enough data, then you can develop models, right? I mean, machine learning, deep learning models at the end of the day are statistically reasoning from the prior examples they have seen.
Mm-hmm.
And so you need to feed it examples where you have described to it, this Paris and this Hilton and this Paris and this Hilton are different, right? And if you don't have enough data that demonstrates that, then the machine learning models can't generalize, can't separate those things, right? And so the challenge in machine learning is, you have to find people who can do the work of labeling this Paris as a location, this Paris as a person, right? But you need enough of that data. And so often what happens is your models aren't performing the way that you would like them to. And it's because maybe you only have one example of a sentence where Paris, maybe you have 1,000 examples where Paris is a location and one example where Paris is a person, right? And if you only have one example, then the model isn't going to be able to figure it out. You need enough examples. And this is where understanding your data set, understanding how your models are performing, being able to collect and annotate more data, or in some cases, being able to synthesize new data, build a whole set of additional sentences where Paris is both a person and a location so that the models can solve for that. So there's a lot that goes into setting up the data to get the machine learning models to ultimately produce the results you're looking for.
So where do customers meet ScaleAI in their journey? Are they at the very early stages where they say, hey, I have a lot of data, I don't know what to do with it? Are they kind of already building a model and they're saying, hey, I need refinement? Or, hey, I have a model, I have a lot of data, but I'm still not getting the right insights out of it. You need to help me get the insights out.
Yeah, I think traditionally, a lot of our customers have come to us because they have some data, they have some labeling, and they are either struggling to scale it up to the volumes that they need, or they're struggling to hit the quality levels that they need. And they come to us because of our expertise in producing very high quality data at very large quantities, a very large scale. What's also happens is, we're fairly well known in the ML AI community for the work we do in producing high quality data. But traditionally, we've really focused on those very large data sets. We're really excited. Just in the last 3 weeks, we've launched an early preview of a new product called Scale Rapid. And the idea with Scale Rapid is that anyone, researcher, student, startup, team within a big tech company, doesn't matter. If you have a small amount of data and you want to label it, you upload that data, you start writing the instructions, and you get scale quality results back, ideally within an hour. I think our SLA is within about 3 hours, but the objective is to get you very high quality labeled data very quickly. And so Scale Rapid is really going to open up for us the set of customers who still need very high quality, but maybe don't have the same level of data volumes that some of our other customers have. But yeah, that product is generating a lot of excitement and enthusiasm very quickly.
Yeah, anytime you can bring a product that, kind of like what you mentioned, to people that are just starting on their journey, you can increase that adoption and utility. I'm curious for yourself on more of your career path. We see on your LinkedIn that you've been in the CTO role at Scale since August 2020. And prior to that, you were working in robotics. What skill sets ultimately were transferable that said, hey, this is what we're doing in robotics. I think this can really apply to helping build AI data models. I'm curious how that leap was made.
Yeah, I mean, some of it starts even before that, right? So, I was fortunate to start my career at Netscape, and then I joined Tellme Networks as the 5th employee. And Tellme did speech recognition, voice automated speech recognition as a cloud-based telephony service. We were using Nuance's core speech recognition algorithm at Tellme, but we were able to get better performance out of that core engine because we had more data and we had better labeled and better annotated data. And so I understood, had the fortunate experience to understand very early on in trying to serve trying to improve speech recognition quality, that it all came down to the data. Yeah, in 2007, I joined Amazon, did a variety of things at Amazon. Again, many in the software world, but at this intersection of AI, I was fortunate to help attract some of the original scientists, the Alexa team. So I've always been at this kind of intersection of software and machine learning and AI. Yeah, I was fortunate to get the opportunity to lead robotics at Amazon, everything from inside the warehouse robotics to the sidewalk delivery program and the drone program. Again, all of that comes down to, if you're trying to teach robotic systems to perceive, whether it's backyards or suburban sidewalk environments or inside a warehouse, picking robots, it all again comes down to the underlying data and the data quality. And so a huge amount of what we were doing was, how do we get more images of backyards for drones, and how do we label those, right? And how do we get higher and higher fidelity information about sidewalks and learn how to navigate those? Or how do we deal with the diversity of all the products that Amazon sees if we're trying to develop robots that could pick up items and place them in boxes? The challenge, again, always came down to, how do you get this data? And so loved what I was doing in robotics, but variety of reasons was looking to get back to the hypergrowth startup world. And I reconnected with Alex. I've been connected with Alex Wang, the CEO of Scale previously, and started to kind of riff on where he wanted to take the company. And really what resonated for me was, I felt that the AI ecosystem was really focused on model building.
Yeah.
And how do you build these models? How do you evaluate model performance? And it felt like it was just missing the mark. Like everything I was doing in robotics, the model building was not the hard part. The model building was, we tuned some hyperparameters. We solved that in a few days or a couple of weeks. And then we were spending months and months or years trying to get the right data, trying to get it labeled correctly. And really there were no tools or infrastructure to help us with that. We were having to build them all from scratch. And so every time I hired a group of scientists, I also had to hire a big software team to try to build them custom tools. And it just didn't make sense. It felt like there was a real market need. And as I talked to Alex and what we were doing at Scale, it was clear that Alex got it, Scale got it. We shared this deep resonance that this problem needed to be solved. And so I'm super excited to join and help build out that vision.
So, you hit on a really great point, which is you identified a problem. Most of the problem was actually collecting enough data to teach the model. It wasn't the actual modeling. It was actually like, how do you make it more? You need more data to make the model more accurate. The more accurate the data, the more accurate the model, the more accurate the model, the more accurate the results. I mean, that's the lineage of information there. I have a question. I tend to tell questions. If you listen to this podcast, I tend to ask two questions at once. I always do it, but here we're about to go. I think the first question is, why is it that so much data is needed? Because for someone who's not let's say not a programmer, for us to recognize an object is quite simple, right? We see a person walking on the street. Oh, that's a person. We don't need to say, I need another picture of a person to know what that is. Like we know it, right? And so for a person who's just thinking like, if a computer needs to see what I see, how come it's so hard to program what I see? Because I see it all the time. Then you said that you help collect more of these data sets so that it's more clear to the computer, hey, this is exactly what's going on. But how do you collect more data than what is available? And that, I think that's another major question is, why is it so hard to do? And then how do you even begin to do it, which is collect more data than I already have? That seems, because I can imagine, let's say, I won't name any names, but you probably worked with companies that are, let's say, owned by maybe some private equity guys that are like more spreadsheet people than business people or tech people. And they're just like, what do you mean? Just get more data. Like, just, I don't understand. Like, just do it. Right. What do you mean I need more? I got a lot. Like, it's plenty. I'd love to hear your perspective on, explaining to a person that is not familiar with what you do. Why is it that it's so hard to collect enough data points to make it accurate? And then I'd love for you to explain, some of the challenges that go behind teaching the model so that it becomes more accurate? And how do you even go in the process of collecting more?
Yeah. I mean, the human mind is amazing as to how quickly it learns. And yet also you're feeding the mind, a year and a half's worth of, 16-ish hours a day, 12, 16 hours a day of video continuously for a year and a half before you can really segment what's going on around you. Right. And so, again, our brains are amazing, but the amount of data they're processing and learning from is quite vast.
Yeah.
Right. And so the challenge in machine learning ends up being you can learn from a relatively small number of data points, right? You're trying to learn, a mathematical function at some level of, what's going on. And so, if you don't need massive amounts of samples to learn some things, right? And yet what you need is those samples to be labeled perfectly.
Yeah.
Right? Because if they're labeled ambiguously, then the model can't actually decide what exactly is signal versus noise. So one way to solve that is to throw more and more data at it, right? And so, eventually you have enough data that the algorithms learn, okay, this is the signal and all these other pieces are the noise, right? If you get really high quality signal, though, you can learn that signal very quickly if there's not a lot of noise in it. So this is the classic trade-off of how much do you invest in getting more data versus how much do you invest in the quality of the data that you're labeling and annotating. In general, the answer is you ideally do both. You try to get a lot of data and you try to label it incredibly well. But even then, there's what we kind of refer to as the long tail problem. There are a lot of artifacts you'll see in the world that you see very infrequently. Like I had a strange experience once driving from San Francisco to Mountain View along 101. I'm going 60, 65 miles an hour. And I think that I see a plastic bag falling from the sky, right? And I'm not too worried about a plastic bag falling from the sky, right? And what it ends up being is a seagull tried to land on the highway right in front of me. There was some roadkill or something on the highway I was going for. And unfortunately for the poor seagull, I hit it and the seagull didn't make it, but I and my car were fine. But the point is you don't encounter that instance, very frequently. How many times am I in my lifetime going to see a seagull fly in front of a car? But you do want to have an intuition as to what to do in that scenario, right? Mm-hmm. If I had just slammed the brakes as hard as I could, I might have lost control on the highway and been rear-ended. And
yeah.
And yet if that were like a baby or a 3-year-old that were then probably I should have you need those kind of data points in your data set in order for, to teach an autonomous vehicle system what to do, right? And so that's what we think of as a long tail problem. Even if you have a lot of data, there are these very infrequent events where you need more data. And that's where we're starting to build a couple products I'm really excited about. One we call Smart Capture, which is you have these fleets of vehicles out there. They're collecting data all the time. A huge amount of that data has to get thrown away because there's just not enough bandwidth and storage to store all the, you've got however many 4K cameras on this thing and LiDAR, you're producing massive amounts of data. You can't keep all of that data. But you do want to keep.
Yeah, you can't transmit it. You would have to build hardcore storage in the vehicle, or it's too much bandwidth to transfer over the airwaves. This is a lot.
Yeah, I mean, AWS has this product of they'll drive up a tractor trailer for your data, right?
Yeah.
So yeah, we should all just drive our cars to some tractor trailer to siphon off all the data, right?
Dock it. Yeah, well, let's dock it to the cloud so it can tell me something.
But you do want to capture these rare events, right? And so being able to smartly capture the data you want and use AI itself to decide which things you want to capture is a product we're really excited to build and kind of integrate with our data lifecycle. There are also ways to synthesize data and to, if you have the LiDAR signatures and the camera signatures of a seagull flying from the sky, you can put that information into other scenarios, right? And create a data set that can see 10,000 instances of that by just, permuting and putting, and we know from the science and the research that models can learn from that kind of composited, augmented data. And so really where we're going with our tool set is that you'll be able to see and understand your data. You'll be able to see and understand how your models are performing. And when you notice that your model isn't performing in this particular edge case, maybe because you don't have enough data, you can push a couple buttons. You can say, I want more data like this. And your fleet of robots, vehicles, drones, whatever, starts feeding you more artifacts that it sees like that.
Wow.
And you can also hit a button and say, generate more like this. And then you can start to automatically see your models improve. And to us, those are going to be incredibly powerful tools to improving models very quickly.
Is Scale already at that place where it's plugged into the actual sensors of all these objects so that you can, from this console of Scale, you can say, hey, I want to collect more. I want to save or keep more images. Like, for example, you use the image of you mentioned a seagull, right? That's obviously in the air. So only certain sensors are even capturing that data point. You can actually tell the objects connected to a central system that says, hey, I want to specifically capture and store this. I guess it would be like at the database level. It's like, hey, keep these records. These records can go. That's where you're headed, or that's where you are.
Yeah. I mean, what we do today, obviously customers are working with us and sending us data for labeling and annotation, right? And so
Gotcha.
We see the data that they see. We can't use it for other use cases, but we can work with them to improve the quality of their data because that's how our contracts are set up. And so we have powerful tools like our Scale Nucleus tool that let us explore that data set and find and say, hey, do you know that you have, this many scenes of white trucks at night, but that's actually, not as many as we would expect for the type of, problem you're trying to solve, with us in the next few weeks here. But what we're working with our customers on is wiring that back to the actual source of those sensors. And so today we have this powerful exploration tool. And yeah, there's just a lot more power as we start to wire that back to the agents that are collecting that data.
No, yeah, that's super fascinating stuff. We keep hearing, and you mentioned some of these use cases. I'd love to hear some of these use cases of what you guys are trying to solve. Because it's one thing to do some document processing, which of course is, one of the use cases that you have on your website. But this use case you're doing with autonomous driving, would you say that's is that the biggest challenge? Or I guess, what are some of the major projects that you're like, wow, this is a hard one to solve, and you're really taking some joy in trying to figure out how to solve it? Because I would imagine that conversation when you have a team meeting is like, hey, how do we do this? Everyone's like, I have no idea.
Yeah, no, I mean, it's, we're super fortunate because we get to work with the most ambitious AI projects on the planet.
Yeah.
And unfortunately, we can't talk about a lot of them.
Yeah.
But there's incredibly neat stuff happening. Obviously, the autonomous vehicle space is a hot and interesting space. And there's a lot of work going on there and a lot of opportunity. But, we're also seeing a lot of work in augmented reality and virtual reality. There's a lot going on in that space that's very interesting. And this problem of high quality data isn't just restricted to these kind of future sci-fi drones, but also to, day-to-day challenges like e-commerce, right? In e-commerce, the marketplace you have is trusted because the information you have about products is of very high quality, right? If you have low quality information about products, people can't trust it. They're not going to buy those products, and they may not want to buy from your marketplace, right? And so there's a lot of space. You hit on document as well. Document processing, super challenging problem, but global logistics rides a lot on paper.
Yeah.
Insurance, mortgage, finance rides a lot on paper still. Medical rides a lot on, this merge between paper becoming electronic records, but still being kind of unstructured like paper. And so there's huge opportunities there to really help people clean up and process that data. And again, quality matters. If you're, extracting the shipper information from a bill of lading, you don't want to get the wrong shipper, right?
Yeah.
Or you don't, you're trying to to get the manifest of all the inventory. You don't want to miss some of the inventory in that list. And so, yeah, this basic workflow of how do you get great quality data to build high quality models to get very quality results for production use cases fits in kind of all of these industries.
No, yeah. The personal industry the industry I'm most personally fascinating is some of the AI work that's being done in the medical field, where a lot of companies are trying to better identify definitive sources of cancer, sources of, potential gene problems, like really, some of the nastiest diseases that we as humans have to deal with, like detecting and finding them earlier. You're probably familiar with the size of the medical records.
Yeah.
Like an MRI file. It's bananas how big these things are. And we kind of rely on like one doctor to look at it. Like that's how we do it, right? We're like one doc.
Well, I mean, medical records are amazing because they're a combination of shorthand, billing codes, which are sometimes, close approximations to what actually happened.
Lots of handwritten stuff too, like handwritten. Like it's not even a document, it's handwritten. Just someone just scribbled some notes down.
And diagnoses aren't even entirely definitive, right? So
yeah,
you're looking at a medical history, and I mean, I was talking to a doctor recently who was pointing out that they'll pull up the records of patients, get someone into the ER. If they're stable, the first thing you do is start reading about them, right? But as you're reading, you really want to definitively know, does this person have this or processing that, because it changes your treatment course. But even the history and the records don't show you entirely clearly. And so then trying to build AI off of that becomes that much harder, right? I mean, fortunately, doctors are really sophisticated, and they can be like, okay, this person is being seen in this part of the, by this type of expert, and this type of expert tends to refer to this type of condition using this terminology, and this other expert so they can translate, right? And building all that sophistication in AI systems, given the current quality of that data, is an incredibly challenging problem. Super interesting problem and massively impactful, right? The same type of transformative, that autonomous vehicles will have on the world when we can really understand patient histories and how different drugs and different treatments will affect them and really personalize the medicine. It's that's going to be equally transformative.
Yeah, I mean, that's definitely one of the big ones that I think about all the time, that I think when this happens, it's going to forever make society better. You mentioned earlier your example of the seagull, and it's also dawned on me. There was that incident where I believe one of the Tesla vehicles got in a wreck because a specific type of truck on the horizon line was not identified. It did cause a fatality, but Elon Musk spoke on behalf of Tesla and said, hey, we didn't have that scenario. Like you said, we didn't have that scenario identified, and now it's been identified and it's been solved. And so I started thinking, and I'd love to hear your prediction on this. It feels like once the abundance of data is captured and labeled properly, right? AI is really going to take off. Like it sounds like we're still in this phase where, because we're still in the capture, label, identify phase, as much as it's taking off, it really hasn't. I feel like once it becomes very clear, like this first two steps, like you mentioned, are solved, then the solutions will start coming out exponentially faster. It feels that way to me. Where would you say we are in like that curve? Like, do you think how many years away before like AI evolution is just going to be like I don't know. Are we going to ever get to a place where it seems like AI solving this and solving that? Like, and how fast can it stack? I know I don't have like a good way of describing that because we're not there yet, but I'd love to hear where you think we are in AI's evolution to the point where it can solve most of the problems, and how fast do you think problems are going to be solved in the future? I'd love to hear this, because it felt like when Elon Musk and that Tesla problem first occurred, I felt like he came out within like a week and it's like, this is solved. It's not going to happen again. I was like, what do you mean it's not going to happen again? Whereas like, a normal manual problem, like, like if your washer and dryer has a bad part, GE would have to do a recall. It would take, a year to collect all the washer and dryers, right? And this is like, oh, we solved it. What do you mean you solved it? It took like a week. They're like, we're solved.
No, I mean, it is amazing, right? That if you have the data and you can, focus the model on that part of the data, And then a big part of production ML systems is the continuous integration, continuous deployment piece, the model CI/CD work, where you put those tests in to validate that it never drifts, right? And so, without knowing a lot about that particular Tesla case or how they solved it, this notion that when you see a problem, right, and we would have this in robotics and Amazon, we'd have this in speech recognition, right? In speech recognition, you talk about autogrammar responses, right? We just didn't expect the human would say that, right? But once they do, you can fix it by making sure that you've got the data set up properly to address that. And then you can build the model CI/CD test cases to make sure that you're validating that going forward. And so the cycle can be very quick if you have enough data. If you don't have enough data, then the cycle can be slow. It's obviously like $1 trillion question as to how fast all this stuff will happen, right?
Yeah.
I do think it's going to continue to accelerate, or the tools will keep getting better, and we'll start to kind of automate this. You can see I was starting to paint a picture of this kind of automated data flow where the data starts flowing in automatically to improve the models that you have. And if we can close those type of loops, it'll evolve more quickly. On the other hand, I look at the history of speech recognition, right? And I mean,
yeah,
researchers have been working on speech recognition and synthetic text-to-speech since the 70s, right? So 50 years of work in that. When I was working on it 20 years ago, nobody had enough data and we didn't have enough compute. It turns out in speech recognition, a lot of the original algorithms, in order to make sure that they could run on the compute of the day, they would do this pruning algorithm where they were trying to search for which were the likely candidates that matched what the human just said there, but they would prune off paths that seemed less likely. Well, it turns out in pruning, you increased error, right? The whole idea of pruning was to reduce the amount of CPU while minimizing the amount of error you introduced, but you did introduce error, right? And so as computers got better, and I mean, tell me I was there from 1999 to 2007, the computer, Moore's law brought us a few more step functions in improvement, and we were able to tune down the pruning. We got less error as a result, and we got better speech recognition. Now, though, if you look at what, I'm a huge fan of Nico Strom. Nico Strom is the distinguished scientist on Amazon Alexa. He's also was at Tell Me, good friend of mine. He published a paper a couple of years ago where they're now using 1 million hours of speech, 10,000, I think it's 10,000 hours of labeled speech, but 1 million hours of unlabeled speech to produce the acoustic models now. And that type of data, you couldn't get that type of data. You couldn't get 1 million hours of speech. There was no place to store it, but there weren't agents collecting it. And then you didn't have the compute to crunch it down. So the cloud has enabled you to go after these very large problems. But now, I have to be careful not to say her name because I have a device in the corner of this room here. But
Alexa. I said it for you.
These devices, I mean, the speech recognition is just incredible, even in noisy conditions, even far field. At the time Amazon started on Alexa, no one really knew if you could actually get good speech recognition from a far field microphone because there were no data sets that had done it.
Yeah.
All the data sets were from a microphone or from a phone, right? And so the progress is, like, on the one hand, it's incredible. On the other hand, it sometimes just takes frustrating longer than you would expect. But again, the bottleneck is really data. And that's where Alex's vision has always been to accelerate AI. And I think what we're trying to do is make that data problem go faster.
So you hit on a couple great points. I mean, I 100% agree. Because I'm thinking back to, I had a Roomba in 2005. And then I saw one recently. And it's still, it's gotten better, but it still has this erratic behavior where it's all over the house and picking up. And you think oh, haven't they figured out how to do this yet? And then someone asked me when is a Roomba version of a lawnmower going to come out? I was like, man, based on this, I don't think you can have one. It's going to chop down so much stuff that you don't want to get chopped down. It's still learning. It's still learning. They're still learning the models. And then I'm based on what you also said, I'm convinced that the cable companies are some of the bad customer service subscription companies. They've just removed the word cancel. Like they just decided to take it out of the chatbot because every time you type in cancel, like, what do you want? They make it, or maybe they are programming it to make it so hard to cancel that you can't do it. You know, the final thing I want to touch on is because you hinted at the CEO of Scale twice now, Alexander. You mentioned that you had met him prior to joining and you were a big fan of his work. Now, he is one of the famously young superstars of the tech world. And he's an MIT kid. He's a man, but he's an MIT guy. You're an MIT guy. You know, first of all, how did you meet him? But when did you know he was on to something? Because he's been in the news. I mean, he's been in the news for, but I mean, it's weird to say a while because like I think I first read about him in 2019, and I think he was like might have been 22 then. I don't know. He was a young guy then. He's still a young guy now, but like he's been thought of as a thought leader in this space for quite some time now. When did you first meet him? How did you guys meet? And then because you had mentioned you were like very fascinating what he was about and like, hey, I want to join you with this.
I met him about 3 years ago. I was introduced through a mutual friend in Silicon Valley, and I think he was both reaching out just for insight and advice that he was growing the company, but I also think to see if there were things that Scale at the time could do to help robotics at Amazon. And I just remember being incredibly impressed by his natural understanding of the problems and the bottlenecks that those of us who've been trying to get, whether it's speech recognition or robotic systems working for a long time, were running into. Like he understood those problems innately and spoke very, very thoughtfully about them. And I just remember thinking he was just a sponge, right? He was just learning at an incredible rate. And so, at the time I often take these conversations, these calls as a favor to friends in my network. And because you kind of never know where they're going to lead to, and you never know who you're going to meet. Right. And, sometimes I've met people who in the future come and take on a big team or team responsibility for me. Sometimes I guess I meet my future boss. Right. But yeah, that's what I was impressed by, was just, he really innately understood the problems that we were trying to address in getting ML systems into production. And he was just learning at an incredible clip. And then as I, re-engaged with him last summer and really talked to him more, what I was impressed with was just how thoughtful he is in trying to figure out what's the right thing for employees, what's the right thing for investors, what's the right thing for customers, and how do we solve for all those? Because in fairness, I've been worried that companies have been taking shortcuts on one of those constituencies, right? And you're very tempted in a startup to maybe underserve one of those constituencies because you got all these pressures on you simultaneously. And I wanted to work for someone and with someone who was going to think deeply about how do we apply all their problem solving brain to trying to solve the optimization function for how we solve for all those constituents. And I think that's how you build a great company. I don't think there's another way to do it, right? Yeah. Like you have to do great for your customers. You have to do great for your employees. You have to care about and take care of your investors as well. And if you can solve for all of that and make a viable business that's making real money, you can separate from the pack and become, hopefully an incredibly successful company. And so, yeah, I got really excited about the opportunity to work with Alex to solve those challenges at scale.
Hey, listen, we're looking forward to seeing how this progresses because obviously, I'm not on the developer side, but I know how much it would benefit me personally. Like everyone, we already talked about driving, medicine, document handling, so many use case applications. Brad, I want to say thank you for joining us today on IT Visionaries. But before you go, it is time for the lightning round. The lightning round is brought to you by the Salesforce platform, the #1 cloud platform for digital transformation of every experience. And Brad, this is where we ask you questions outside of the world of work so our audience can get to know you a little better. You ready?
Sure.
All right, we checked you out on Twitter. Your profile pic on Twitter, you're holding a camera. Are you a photographer? Let's start there.
I'm not a super active photographer, but I do love photography. My dad's a wildlife biologist and a photographer. My grandfather was owned Porter's mail order camera store. My great grandfather was a portrait studio photographer. So yeah, photography is kind of in the blood, in the DNA, and yeah. So I've had a camera around my neck a lot of my life.
There you go. So while you might not do it as much as you'd like to, I'd love to ask, what do you like to do for fun? So photography sounds like a fun thing you like to do. What else do you like to do outside of work?
Yeah, I mean, I have my wife and two beautiful daughters. I spend a lot of time with them. We just moved to California, back from Seattle, so that a lot going on. My kids are at this fun kind of 11 to 13 middle school age. So I'm having a blast with them. Personal hobbies wise, I've always been into things that fly.
Yeah.
And I don't like to put myself into the pilot seat, but I like to do anything kind of radio controlled, whether it's, I've done a lot with RC gliders, slope soaring, thermal soaring, this kind of 3D aerobatics, helicopters. I'll often spend time at night just sitting in the simulator at my computer and learning how to do various flips and tricks with a remote controlled helicopter.
Well, our producer Aaron says he has just chatted me and says you need to do drone photography, so then you can fly things and take pictures.
That's right.
Well, Brad, I want to say thank you again for joining us today on IT Visionaries. Thanks for sharing what you're doing over at ScaleAI. And I thought you did an excellent job of explaining where you play in the AI space. I can't stress enough how many people come on and say, we're AI. And they're like, well, what does that mean?
No, well, very good. We're excited. A lot happening at Scale.
Brad, thanks again. And to all our listeners, if you want to check out some of Brad and his team's work, go to scale.ai.